All right, we are at 2 minutes past the hour. Shall I get started? Or Jason, Shelley, do you guys want to do the introduction, or shall I introduce myself?
Yeah, real quick. I just, welcome everybody. Thank you for coming. My name's Jason Walls from QA Cafe. I apologize, I'm not on video at the moment, but you all get to see Wouter's lovely face. And we've been putting together a webinar series here. I work with the prpl Foundation's marketing committee, and we've been trying to put together a series of webinars on various topics. And since Wouter is now the new principal architect of the prpl Foundation, we figured it'd be good for you to meet him and learn about prplWare, just kind of a big overview of everything we're doing, including how to get involved and where you can get started. And so Wouter's going to show us all that today. There should be some time for Q&A, and if you do so, we are using Zoom, so please use the Q&A control box in your Zoom control panel. That helps us triage the questions a little bit better. Wouter can see them all, and we can figure out which ones can be answered online or which ones we need to follow up with later. Save the chat for if you happen to have any technical difficulties, if you can't hear us or anything like that. All right. If there aren't any other questions, please take it away, Wouter.
Thank you, Jason. So welcome, everyone. I'm fiddling a bit with the full screen presentation. So if things go wrong and it becomes too unresponsive, I'll switch to something else in the middle of this. We went for a who, why, how, and what approach here. So I'll start by briefly introducing myself. I have a crazy amount of slides. I have like 50 slides, so I will go through them very quickly. And the extra detail is just there for you guys to look at later. Just quickly introducing myself, I started programming at a very early age in about 1994. I've been doing embedded projects while still going to school since the 1988. I've started using Linux with Linux kernel 0.95 or something in 1992. Been developing professionally as a career since 1996 or so. I've been engaged in open source since about 2000 when I was working at IBM at the time, contributing to Apache SOAP. I became a full-time open source consultant supporting Linux, ECOS, all sorts of things that I've done there in 2001. As part of that, I deployed some of the first, that was the intention actually of the company, of the open source consultancy company, to prove that open source software could work in the embedded space and could really power mass market devices. So I deployed a payment terminal that I'm sure all of you have used for versions of it in 2004. I did satellite gateways in 2008 that have been deployed around the world. As a couple of examples, I made some open source contributions. My Linux kernel contribution has no attribution to it, so I can only show you the code, but my name is not in it. So in 2008, I hopped from that open source world to the proprietary world, figuring that I can change things from the inside. So I became the chief architect of Soft at Home, gateway architect of Soft at Homes. This was DSL gateways, fiber gateways with its wireless extender specifically for internet service providers, for operators. So that was the introduction in that world. After 10 years, I hopped across to the operator world. I first joined Liberty Global, where I did a Toxis development, and to Deutsche Telekom, where I deployed every technology imaginable. So since the beginning of this year, I've now joined the prpl Foundation. I'm very grateful and happy for that opportunity. But for me, this is coming back to the open source world. So I have a perspective that I'm going to show, which is not the only perspective of the prpl Foundation, but I have the background in embedded development in the open source community, what it's like to be a vendor in this world, and what it's like to be an operator. So let me then quickly introduce who I see as the actors in this specific problem space. Firstly, you have the operators or the internet service providers, ISPs, service providers, whatever you want to call them. They essentially want to deploy devices on their network in the context of this problem here and provide service to their customers for those devices. Then you have system integrators. These may be parts. System integrators do the software stack for these operator gateways, also called CPEs, customer premises equipment. These system integrators might be part of the operators. There are very few tier 1 operators who do their own software stacks. They may be part of the hardware manufacturers or the OEMs. They are not system integrator is not necessarily a dedicated company, but there are a couple companies that are dedicated to just system integrators. So they're the ones who customize software stacks for these devices according to the operator requirements. Then you have application vendors or third-party software vendors, independent software vendors, whatever you want to call them. They provide value-add services. So they may have a combined solution on the CPE and in the cloud that offers a particular service, and they need to integrate together in that device on the CPE and in the operator network typically. Then you have the hardware manufacturers. They produce the devices. They buy silicon from the silicon vendors, and they essentially what they need is device software to put on those devices, especially if they are also the system integrator. But even if not, then they almost always still have an involvement. Then you have the silicon vendors. They produce the silicon hardware. There are very few in the specific space that we're looking at here. And one of the things they need to do is that for their hardware, they have to provide an SDK to support the various use cases. They can't just provide hardware and a data sheet. The complexity is far, far, far too high for that. And then we have a bit on the edge of the problem space. We have the standards bodies, the IEEE, the Wi-Fi Alliance, the Broadband Forum, the Wireless Broadband Alliance, the CSA, and other organizations. What they do is they come together as an industry and harmonize the protocols, the interface, to facilitate interoperability. One of the things they might do is they might develop a reference software implementation or endorse a reference software implementation. So those are the actors. That was the who. And then we go to the why. I've tried to keep it very brief because I have far too many slides. prpl Foundation started in 2015, started by Imagination, which was licensing the MIPS processor cores or CPE instruction set. MIPS was until the mid-2010s absolutely the dominant instruction CPU architecture in the gateway space. And then things started to move in the direction of ARM. So they were doing things in saying that, well, we want to support an open source community to do things that are relevant to silicon. None of it, I must say, was specific to MIPS, but in the early days, the prpl Foundation did have this this name of being specifically for MIPS. It never was. Over time, they built a relationship with the OpenWRT community. Some of that was thanks to Qualcomm joining and Kathy Giori in Qualcomm moving their internal SDK as a silicon vendor towards OpenWRT, which they call their QSDK. So they saw the prpl Foundation, and at this point in time, while I was at Soft at Home, I was involved this already. They started to reach out to the OpenWRT community and funding these summits, which they have been running. The summit from 2015 to 2018 were funded by the prpl Foundation. And we started to create various working groups, making them more and more detailed as we started to refine what we went to do. As of 2016, we actively reached out to the silicon vendors, the gateway silicon vendors, wireless silicon vendors. That's around the time when I published the first low-level API recommendation, and other recommendations started to come in. In 2017, we started the prpl Mesh project in collaboration with the Broadband Forum. They had an open source 1905 stack. they wanted to do a reference implementation of Purple Mesh. So we started a working group to work on them together. Then there was also the development of an OpenWRT-based software stack that was initially called prplWRT. The first release of that was in 2020, and that's been since renamed to prplOS. Things really started to move when in 2021, major operators started to fund the development, to accelerate that, to really get it up to carrier grade. And in 2023, the big milestone was that we actually have first reference hardware platforms available, because before it was just software in isolation. It took I took a lot of time for that slide, but that might be interesting because few people know of the history. So what do we focus on? Not everything. So we mostly focus on operator deployed carrier grade residential internet gateways. So we're not stopping anybody from using prplOS on retail gateways, for example. We're not saying that we don't or will never do small business gateway or anything like that. We will do wireless extenders at some point in time. It's definitely on the roadmap, but this is our main focus. This is what we're working on. What is the problem actually that we're trying to solve here? Following up with remember we're in the why section, right? It is really hard to produce a carrier grade device. Most of the time, you're solving the same problems over and over. That adds risk, that adds time to market, that adds time to market, that increases the cost, and there's really no value in this baseline functionality that's solving the same things over and over and over. For an operator, it's also really hard to introduce a device into the field, then remote manage it and maintain it while it's in the field. And then, especially for the application vendors, it is really hard, and the operators, it's really hard to integrate a value-added service. This is to nobody's benefit. All the actors that I introduced lose here. So it'd be really great if we wouldn't have to focus on solving the same problems over and over, and resolve some of the difficulties there so that everybody can focus on adding value, competing with features that are differentiating between the different companies and that are innovative. So then I'll go into the what, going more into detail of what I just briefly introduced. So what are we going to do here? Well, what do we do in Purple? What is the mission? The way I see it, again, this is my view. This is not. You'll get a different answer from anybody else. So the idea is to collaborate between competing actors. We have competing operators, we have competing silicon vendors, we have competing OEMs, we have competing application vendors, and we have competing system integrators, all working together in the Purple Foundation to commonly fix the common problems that are just that baseline that has no added value. So then everybody can focus on better service, faster deployment, faster time to market, innovation such as the latest features coming in early and not having to spend a huge amount of time on, oh, there's a new version of technology. Everybody has to start doing this integration at the same time. Let's do this together in Purple. Let's compare with the rest of the world. What do you typically do when you deploy, when you have Linux? Well, you have standard hardware with standard interfaces, peripherals from many different vendors. In case of a PC, you might have Ethernet interfaces from Realtek, from Broadcom, from Intel, Mellanox, and countless different vendors. And for some reason, all of this works. We don't have to do a special integration for an Ethernet interface. Typically, there's a standard open source bootloader. Nowadays, Grub is the most popular. The Linux architecture support is just supported in the mainline Linux kernel. Discovery of peripherals, any PC that you install Linux on is just going to discover when it comes up what's all present. All the device drivers are open source because Linux has standards frameworks for all of the different services, and the drivers look into that, providing a hardware abstraction. And there are a whole bunch of different Linux distributions to choose from that package open source software, user space software then. On an embedded system, things are a bit more complicated. You have a dedicated system on chip that not only has a CPU, but integrates various peripherals. Software is generally on flash, not on a hard disk or anything like that. Bootloaders may vary. Typically, the most popular bootloader nowadays is U-boot. You get a Linux kernel with device drivers, but some of that might be somewhat special for that particular system on chip, but generally it's specific to an embedded system application. And nowadays, typically you don't build your own build system and distribution. What you do is there are two big ones to choose from: Open Embedded, which is a build system that provides that together with Yocto is a embedded Linux distribution, highly customizable, and Buildroot, which comes from the OpenWRT world. And then you have a bunch of open source Linux software that's packaged in that. And then on top of that, you build your custom application for your particular embedded device. As meant, I'll give another example that I've deployed, which is a closed circuit television system. So, you have on one of the applications, one of the devices, you have a monitor that shows all of the different screens by IP cameras remotely connected. That application is custom. Everything else is just standard. Okay. So now, knowing what we know about PCs and what on the other embedded space, what is so special about this carrier grade? And what does that mean? What does current open source not offer? Why do we need to do more than what we have? Well, it's really hard, and this is a bunch of slides. First is that these system-on-chip interfaces are not common in PCs. Access network interfaces, DSL, GPON, DOCSIS are pretty much completely absent from Linux, as a few examples. System-on-chips typically also have embedded switches, Ethernet switches, or Ethernet packet switches into them, and making things really specific, hardware packet accelerators that basically steal away some of the work that Linux does and do it behind the covers in a proprietary way. There's more, but this is just a few examples, and those aren't completely modeled in the Linux kernel. The frameworks are somewhat missing sometimes. So this creates an inefficiency in the sense that silicon vendors, each individually, are going to say, well, we have this extra hardware, we're going to create our own interfaces, which are proprietary and custom and only available under NDA. Which means that everybody who uses a particular chip has to use those interfaces. If you go to a next version of a chip or next SDK version of another silicon vendor, you have to do a whole bunch of hardware abstraction on your own again. What makes matters worse is that these silicon vendors very often don't even use device driver subsystems that exist in Linux and choose to develop something proprietary instead, which makes it even harder. So whereas for PCs and for a whole bunch of embedded system on chips, the Linux integration is entirely open source and in Linux mainline, that is almost never the case in this particular domain. The kernel version SDK, so the silicon vendors deliver an SDK, a software development kit or a board support package, if you like. That's not always using a recent Linux kernel, so it might be old and not have the most recent features included in it. Obviously, these different silicon vendors don't coordinate their roadmaps, which means that as a system integrator, you have to deal with different Linux kernel versions. The SDK and documentation are under NDA, and if you want to have reference hardware, that's under NDA as well. So open development on these devices is really impeded, makes it really difficult to do that. You cannot essentially share and work together there. This all results, and I've been there many times in the last 15 years, that if you want to do a gateway on a particular hardware design, it takes about 1 or 2 years to do this integration. So from a time to market perspective, this is really bad. This is even bad for the silicon vendors. They come up with new silicon, and by the time they start selling in volumes, you're a couple of years down the line. Let's see, still doing okay on time. Right. Then remote management. So that's also a silicon, an operator-specific problem. So there is an open source solution for gateways, OpenWRT, right? It is a great basis for mostly an Ethernet-based router and an access point, really giving the power to the end user to configure that via the web interface or on the command line. Carriers have a different requirement. They use standard protocols to monitor and to configure and to provision, as they call it, all of their devices that they mass deploy in the field, and the end user's ability to configure is extremely limited. So there's a bit of a mismatch there, for sure. So the standard broadband forum protocols, those are the historic TR69, the more recent USB TR369, as a remote management protocol. These are supported by a bunch of vendors on the that the operators can buy service from as well, who can manage millions of devices at the same time. And there are the specific ways, these APIs to interact with the devices are standardized in TR181 and TR104 for voice over IP. Configuration via remote management is just not native to OpenWRT. They've done lots of things that are nice and close to the technology, but don't necessarily retrieve or have the configurability of an operator. And the whole part of remote management is just entirely alien. It's usually something that sits on the side and tries to make hooks with all the software components. There's a slide I guess I missed a bit, which is that operators also have very specific, very strange and specific requirements. You might have a DHCP client or a PPP client. That's all fine. That uses its own timings when they come up. But an operator has to take into account things like that. Okay, you have a region, like a city, where you might have 10,000 subscribers, and there's a major power failure in the city. Power comes up, all of the gateways come up at the same time, and all try to do their DHCP discovery or their PPP discovery at the same time. This will completely bring down the network. It'll take very, very long before everybody's connected. So operators are very specific on timings, on randomization. These sorts of things are generally not part of any of the open source protocol implementations. So next is application software integrator, these third-party vendor integrations. We have security vendors, we have IoT vendors, we have vendors focusing on network optimization, which may be mesh optimization, a bunch of vendors doing telemetry collecting data from the devices. They might have VPNs that they set up, device identification, etc. Every one of those vendors, especially if they need to interface with the hardware, for example, for security and for network optimization, for telemetry, you might really need to go and call those proprietary APIs of the silicon vendors that are only available under NDA. They need an NDA with each silicon vendor, and they need to do a specific integration for every device individually in whatever software stack there is with the system integrator, which I've abbreviated to SI here. So yeah, that makes things really hard as well. Next carrier great aspect is telemetry, and that means collecting data from the field, right? For an operator, the issue is that it's always the internet provider's problem. We are the help desk as an operator. The operator is the help desk of everybody using the internet, essentially. Customers will call the help desk for any service that they might have an issue with, any device they have in the home, any wireless problem, regardless of if they bought it something retail, or if they bought it, or if it's a service that the operator provides. Any IoT system might cause an issue, operating system problems on their phones and on their laptops. All of that will end up on the operator's help desk. And it is not really an option for an operator to say, not our problem, go away, solve your own problem. They are in the business of helping their customers. And it's really important for customer satisfaction. So what do you need to do? You might have a customer who is, well, most customers don't really understand this technology. So it's really important that you are capable of gathering the data that shows you the home of the customer so you can help them. Right. And you also need to monitor, monitoring field deployed device health is also important. So you continuously want to improve your product. If you see that some of your services are crashing, that your flash is filling up, that your RAM is filling up, that your device is rebooting very often, that you have glitchy connectivity, those are things that you really want to know, because you want to know how good you are actually doing in the field without your customers telling you, because they can't see what's going on. So especially when you deploy a new gateway or new software version of the gateway, it's really important to follow these things up. Then software update. OpenWRT has a great solution. OpenWRT has this OPKG, these modular packages. You can install every package individually, but there's no actual verification before you install the package that there's even enough flash available to upstep it. So the individual software upgrades of OpenWRT are somewhat questionable for a use case of an operator, because you really don't want an end user to do this. You don't even want to do it yourself. What you really want to do is rigorously test a particular combination of software packages that you have on your device before you do a field upgrade. That rigorous testing is very expensive, takes a very long time. You're not going to offer every possible permutation of every application and every configuration. So there has to be a good solution for software update as well. Next is, and I'm not really describing the problem in the title, I'm describing the solution already, is that this remote management, well, there are a whole bunch of devices that have proprietary data models, and there are even some operators that deploy proprietary or their own in-house developed management protocols. That's great. Sometimes there's a really good use case for it. However, it's really costly to maintain. And when you roll you're on your own, so you can't go to just any vendor and say, I want a solution that solves all these things for me. And this really makes it hard if you want to then introduce a new device from a new vendor, new system integrator, new OEM, whatever, that has a different data model. Now you have to scratch your head in that, how you collect data in a common way, how do you do your provisioning in a common way. This really increases the cost and complexity quite a bit. Then besides remote management, there's also wireless. There has been in the past an absolute plethora of different wireless mesh protocols, entirely proprietary, that require custom development in a gateway that you're going to deploy and in extenders as well. And then you have these devices in the field that your customers aren't happy to just replace them after 2 years. So you have to maintain them in the long term. Very painful. So how do we fix these things in prpl? Well, to begin with, we have a low-level API working group, which fills the gap. Any interfaces that are not part of Linux, we define specifically. We say that, okay, this is what you have to use as the Linux interface. Most of the focus has been on convincing silicon vendors to use in their SDKs and in their device drivers, things that were already present in Linux. The most important of that was wireless, because that's the most complicated one. But now we're focusing we're also focusing on things that just aren't present in Linux, and hope to be able to contribute to fill those gaps in the future. Next is the integration with a silicon vendor with Linux. To begin with, we have a particular cadence that we now set in prpl, and we say to the silicon vendors, look, listen, these are the real long-term supported kernels. We'd like you to follow this particular cadence. Then the problem of the hardware being under NDA. Well, what we've managed to do with 2 silicon vendors so far, and hopefully more will follow. So far that's MaxLinear and Qualcomm. We have prpl reference platforms that you can buy openly, that the silicon vendors support, that have the latest flagship system on chips, because we currently have a to Wi-Fi 7 based platforms, XGS PON and everything as well for the Max Dinner device. Anybody can buy these. So you no longer have to have a special NDA with a silicon vendor, and you no longer have to buy a difficult to obtain reference platform. We can all share the same devices between us. Full source code, well, source code mostly for the, not all, necessarily all the source code, but all the code to be able to make a build is available. Sometimes that requires a light NDA with the silicon vendor, and the prpl Foundation continuously develops and tests these on prplOS. Then when it comes to remote management, we have a high-level API working group that is essentially defined a microservice architecture, which is more closely aligned with the TR181 data models that have particular parts of the data model that address individual types of functionality. And these are entirely have natively focused towards these data models. And anything that we do in those, we align with the broadband form immediately. The operators in the prpl Foundation also currently give us use cases and say we want to do these and these and these things, these special functionalities, carrier grade functionalities, and we then take it together with the operator, run with it, and go to the broadband forum and propose extensions to the data model, and then do the implementation. So we have a very close collaboration with the broadband forum on all of this. Also on the integration of this universal service platform, sorry, universal services, sorry, TR369 USB, the meaning of the acronym slips my mind at the moment, which comes from the broadband forum. So in the code repository of the broadband forum, you will find OB-USB-A. We take that code and we integrate it into prplOS. On top of that, this standards issue, standard data model issue, we have the ability to test and enforce that. So the prpl, that's the first certification that the prpl Foundation can offer, is a high-level API certification, where we allow, I have a slide on this, you to verify that a device really adheres to that. More certification will come. Quick picture on the microservice architecture. Essentially, we have a bunch of applications that offer a particular data model, and we have an application framework called MBOX. It's really a whole collection of different libraries and utilities that allow you to very easily to create a TR181 data model as a controller, in the words of USB, as a data model supplier, and use a data model as a data model client, it's an agent, and a controller is the one that uses the data model as a data model client. So the way this works in prplOS specifically is that we have the OpenWRT U-bus inter-process communication mechanism that allows different applications to speak to each other, and all of those services plug into that with the U-bus backend of MBOX. There is then a sort of a bridge between the U-bus and the USB space that interfaces with OB-USB. We have a TR69 client that's still connected to U-bus at the moment, and the OB-USB-A allows internal communication between services that use USB locally and the remote USB controllers in the remote management space of the operators. We've done more than that for application portability. We have our LCM solution. I'll get back to that in detail. And the LCM applications aren't specific to an OpenWRT basis, so they don't use U-bus. The same MBOX framework, by swapping out the backend to the USB backend, allow to connect natively to USB. Okay, next one. There we have it. So that's the application software integration. These the LCM working group, Lives and Software Code, Lifecycle Management, offers a standardized way to deploy an application. So you'll remember that for software update, I managed that operators don't really want to deal with this. However, if we very heavily isolate the application, if we have a standardized interface to this high-level API and these TR181 data models, standardized interface to remote management, and ensure that there is access control to see what the application can or cannot do fully under the control of an operator, then we actually can deploy applications. And it's essentially the idea is that you have one application code base that'll work on any router. It doesn't have to be prpl based. You have to build it because for every instruction set architecture for ARM x86, of course. And if you want to do a proof of concept as an application vendor, you can walk up to an operator or a system integrator and say, okay, how about I have an LCM deployment unit for you. How about you just install it and see if you like it for a proof of concept. Further integration will be needed to really deploy together. But this first step, I know this from being an operator as well. You have all the vendors knocking at your door, asking to do a proof of concept. And all of those are 3 to 6 month projects today. So if we can just say, how about you just install this and take a look at it and see if you like it? Huge game changer. Then standards alignment. This is also critical. So we have, as you noticed, a good collaboration with the Broadband Forum, but we also align with the Wireless Broadband Alliance, the Wi-Fi Alliance, Connectivity Standards Alliance, that's the CSA that maintains the Matter IoT specification. And for wireless and specific, what we have is the prpl Mesh working group and piece of software, which is probably the largest project we've ever done in the prpl Foundation. It's an open source reference implementation of the Wi-Fi Alliance Easy Mesh protocol. I did not know that this slide I copied from somewhere else. So this is that was animated. Sorry, that's the first time I've seen it. So the prpl Foundation has a board of directors. I'm not going to go into the details of that. It's probably not that interesting. We have a product steering committee that decides what's going to happen, a technical steering committee that oversees architecture, a marketing committee. And then we have the different working groups. It says here the Gateway Product Working Group. That's maybe a bit older. We're reviving that sort of in an architecture working group. We have the LCM working group. We have the security working group. We have the prpl working group. We have the low-level API, the high-level API, and prpl Mesh. So if you want to get involved, and then the collaboration with the standards. So what does a prpl architecture look like, and why are we referring to prplWare, and how does it relate to prpl? Well, here's the high-level picture, right? So prplWare is all of the different software that we support. Some of these are these TR181 native services that we put into a prpl, which on the northbound have this TR181 high-level API and communicate via USB to remote management. And via the low-level API, if necessary, interface with Linux and the hardware. That's the basis of it. But not all of the products, or not all of the software packages that we do are deployed on prpl. prpl Mesh and LCM also works on RDKB, which we also maintain. So these are portable. By virtue of Ambiorix having the pluggable backends, we can deploy these on RDKB as well. So prplWare covers all of this. prpl is a specific implementation of prplWare based on an OpenWRT basis. Right. So I've explained most of these. The certification and security assurance working group sit a bit on the side. I've got some other slides that will show that a little bit better. I'm going to go fast through these slides, are not that interesting. The low-level API recommendation is something that you can download from our public website. We're focusing on a bunch of new things in 2024. But the really critical new technologies, we already had an alignment on how to do them in 2023. That includes how we're going to integrate the cellular fixed wireless access or cellular modules, system-wide, mesh-wide quality of service, Wi-Fi sensing, which is a new innovative topic, and Wi-Fi 7. This is what I mentioned. So we host all of our layers mostly openly or via a light NDA, which means that, and this has incredible value, that means that the prpl Foundation does all of this initial integration and quality testing so that the system integrator doesn't have to get some SDK from a silicon vendor or multiple silicon vendors sometimes, and has to start integrating all of it. It's all done already, and all of that code is recoverable. This is unique in the market in this problem space. Aligning of the Linux kernel versions, we try to align that with the rest of the community, with the Linux long-term support kernels, with the Android common kernels, and then we align with OpenWRT and RDKB as well. So we are mostly on 5.15, moving towards 6.1, still have some 5.4 hardware. So we've been able to convince the silicon vendors to align a bit better. This is a complicated slide, but it's a really important slide because it's hard to explain what we do. Outside of the Linux space, there is so much more. The system integrator will build the software image. Fine, we have our prplOS. Will then sign that software image because a carrier-grade gateway is a lockdown system. You can't just deploy anything else. So we have to provide a signature and signature verification by the bootloader and by an entire secure boot mechanism. So this image signature is something that we're working on. Standard format, because now this is common, is custom for every silicon vendor. Standard format, standard signature, standard tooling. And then that can be handed to the manufacturer to write into Flash when manufacturing the device. And it can be via software updates. We can do the deployment as well on the device without having to have silicon vendor specific tools is the goal. We're working on this. What we already have is a standardized Flash layout. So the LCM applications and data in a partition. Other data is our configuration data is in a separate partition. Then we have two different software banks, the current and the previous software bank, to be able to securely switch from one to another, where we have the last stage bootloader, a secure application environment application might have that, the Linux kernel and the root file system signed by a key. We also have the ability, worked on secure manufacturing data, essentially. Basic things such as what is the serial number of the device, what is the MAC address of the device, all needs to be done. We've standardized what this looks like in Flash and how this needs to be done and how this is signed, so it can't be changed. And that also makes it easier to deploy a device unique key and certificate to the device, so it can identify itself with the remote management systems. So this whole secure boot chain we're working on to get that aligned on our reference platforms as well. And we're also working so that when you need to do a cryptographic operation, you don't need to have the key. You can just call a trusted execution environment, which is also not so typical in the space outside of secure embedded devices, which will have access to this, device, not even exposed to Linux at all, is the goal to be able to get to. Beyond that, there's all sorts of work to provide interfaces to the containerized LCM applications for privileged features that they need to do. A security application that wants to inspect packets on the network, for example, will need to interact with the R firewall component, which will allow us only send the packets that the operator configured that are allowed. And the intent is also to develop a security incident response scheme for any security problems so that we can immediately update this and push it to the operators that are deploying it. prpl Mesh, I'll skip over it. It's essentially, well, like I said, an open source reference implementation of Easy Mesh. But in addition, it also takes over wireless management, which is a bit of a nightmare to do properly at a carrier grade level. LCM, I've explained it. It's a microservice sitting in a sandbox. An app store is maybe something that is not typical for operators, but it's the same basic concept. You have native services, and you have services that are that we want to be able to deploy after the deployment of the gateway. So we have this concept, and all of the things that go with the sandbox and the isolation come with that. I'll skip over it so that I can have more things. What have I further been doing to improve the work of the prpl Foundation since I joined since the beginning of the year is the establishment of a platform team that interacts with the silicon vendors and the ODM for our hardware targets. That provides feeds and meta layers for prplOS and the RDKB stack for RDKB support on these reference targets. The security and low-level API working group don't develop code of their own. They audit what happens, and they to ensure these things. I'll skip over the rest of it mostly. And any data model definition goes to collaboration with the broadband forum. Feature lifecycle, I'll skip over it. The platform support. Certification is the last topic that I want to touch, the certification working group. This is the chair of that is Tim Winters of QA Cafe. So we do have a collaboration with QA Cafe. We have an implementation of the first certification, the high-level API certification that exists, which runs on CD Router 1.14. So certification, the intention of that is that that you can do self-testing, and then we give you all of the tools to verify that your device is actually compliant, and then you can submit the results to prpl, pay an application fee of sorts, and then we will publish devices that are in the field. This is a good way for an operator to keep their silicon vendors and OEM honest, to insist that the devices go through certification. We plan to do much more. We plan to do application certification and low-level API certification in the future as well. And that's about it. So I'm open to questions. I've seen 2 questions so far in the Q&A. The first is, which hardware platforms are you planning to support in the future? Perhaps some easy to get reference platforms like a Raspberry Pi or a Banana Pi. A Raspberry Pi is a horrible target for a gateway. It has one Ethernet port. It has one wireless interface. It really is not that suitable. What we have been using is the great Turris Omnia. It's a bit old. It's Wi-Fi 5, but it is still the reference target for prpl Mesh, for example, because it needs to work on both prpl OS and on RDKB, and that's the target for which we have RDKB support as well. The Banana Pi, there's a Banana Pi R3 and R4 that are MediaTek based. MediaTek is a member of the prpl Foundation, and there is pressure on them to perhaps say that these very affordable Banana Pis would be endorsed by them as official reference platforms. Second question, will there be cheaper reference platforms available? Yes, this is true. The WNC Qualcomm-based Haze and Freedom boards are not cheap, nor are the Gemtek-built MaxLinear OpenServe OSP and OSP v2 platforms. But these are really, really high-end platforms that offer an enormous amount of flexibility and functionality. Again, the Turris Omnia at the moment is the best option until we have maybe something better. CD Router, yes, indeed, is the only way to provide high-level API certification testing. I've included a link to our previous webinar, which was specifically about that certification. How does an OEM that is a member of the foundation become part of a working group? That's really easy. You can send an email to info@prplfoundation.org. You can say that I have an interest in this particular working group. You will be added into a group that automatically invites you to the working group, and you will have access to our Confluence space and to our Jira, in which the members-only information is available. So once you know when the calls are of the different working groups, just hop in. We'll notice that there's somebody new and we'll offer to onboard you. I'm just going to click that I answered these questions. Okay, next. What is available today with Wi-Fi sensing? Well, we've done a first phase as a proof of concept. The problem with Wi-Fi sensing is that the 802.11bf is not, it was still in the making in the IEEE, and every silicon vendor created a completely incompatible protocol, proprietary protocol, with a proprietary low-level API. So there is an integration done with that just to prove that this works, and this was demonstrated in the 2023 prpl Summit. But what we're going to do in 2024 is lock that down and say, and move towards 802.11bf, move towards a standardized low-level API, and so many more use cases that we've created at the moment. After this webinar, I am going to start sending out a doodle for a separate working group specifically for Wi-Fi sensing. So if you have an interest, please reach out to me and I'll include you as well. How can Wi-Fi telemetry be pulled off prpl in real time? Are there any REST APIs that an application can consume? Well, there are multiple ways of doing this. You can have an agent. So remember that I spoke about applications that do telemetry. Well, you can deploy a telemetry application that connects to your own application vendor cloud, collecting the data there, and it can inspect the data model internally. So anything that's available on the data model is available internally inside the gateway and via remote management protocols, TR69 and USB. So you can do it in that way. Just have an agent collect that. You can be an operator and say, I'm going to collect that data via the data model via remote management. That's not so suitable for real time. That's a bit of that's the tricky part. You can also do filtering of that data in the application in the CPE itself. So you might do some pre-analysis and only send across particular alerts and start sending data at a higher rate if you've noticed that there is a particular anomaly or something happening. All of these use cases are things that we simply support. We don't particularly endorse any particular solution. We make sure that prplWare supports all of this. When it comes to REST APIs, it's not a REST API, right? So if you're natively working inside prplOS, what you have is this. Do I have a good slides that might? So I have something to point at. No, that's not what I wanted. So I can't find the right slide right away. How about I stop this presentation and start searching through the slides. I clicked exit, but it's not responding. Okay, there we go. Sorry, here I have my slide deck. And I have this particular picture here, right? So you might be an application in here. You can subscribe in real time to anything that's happening anywhere in a microservice to get notified of changes. You might poll internally, be a bit careful, of course. And there isn't really a REST API. Now, what does exist is that if you want to do this via monitor what happens via the web UI, to my understanding, I'm not sure of the details yet, there is a way via HTTP to get onto the internal IPC bus as well. So our own local web UI in prplOS is written in this way, so you can collect information from there as well. That is I think a JSON RPC style interface, which is the closest you can get to a REST interface. Okay, well, detailed question. Somebody did homework. For certification, I've read in the PDF, the prpl program guide for certification tests, that the applicant has to complete the additional requirements before applying. What are those additional requirements? Are they more than basic things like providing the model number and the organization name of the applicant? Is Tim still with us? Sorry, is Jason still with us? Tim couldn't make it today.
Yeah, I was gonna just follow up to that next question that you're about to ask and just point to I believe that the certification program working group email address is cert@prplfoundation.org. That's the best place to ask that question, I think. The question was some procedural stuff around the certification tests and about completing some of the requirements. So to get a good response to that, just send an email to oh, here it is. I'll put it in the chat. It's cert.twg@prplfoundation.org, but I'll put it in the chat.
Somewhere here there's a slide. Hey, there, I found it. That's the okay, so that might be good to put in the slides afterwards before distributing. Okay, next question. Does the prpl support the low-level API and high-level API on MediaTek and Aeroha-based SoC platforms, and is it on the roadmap? MediaTek and its Aeroha subsidiary are a member. They do join. MediaTek over the last few years for their system on chips have been putting in a lot of effort to be low-level API compliant. And I can tell you that the Banana Pi R4, of which I have one, is really good, actually up to speed. But it is not a prpl reference platform, so we don't put any effort into it until MediaTek decides to support it. Aeroha is a bit more complicated and is more interesting because they also have DSL and GPON support, which the MediaTek chips don't have. Is it on the roadmap? It's not up to us. We request the silicon vendors to do this. We recommend that they do, and we want them to do it, but it's up to them. Okay, next question. By the time system integrators release the silicon vendors release their SDKs, OpenWRT and Linux releases are out of date. How does prpl solve this problem? How soon is after the silicon is available, will prpl be supported? That's a difficult question at this point in time. So in 2023, we released reference platforms based on Wi-Fi 6, which is still fairly recent. And then in late 2023 and early 2024, now we have hardware that supports Wi-Fi 7, which really is the absolute latest hardware that is out there. So certainly when it comes to Qualcomm and MaxLinear, their very latest hardware is there with full prpl support. Going forward in the future, we hope that this will happen for all silicon. Now, their SDKs, OpenWRT and Linux releases are out of date. Yes. So I mentioned that. So we pressure the silicon vendors to upstep to newer versions of Linux. In many cases, we're in pretty good shape. Qualcomm is moving towards 6.1 on their Wi-Fi 7 platform, and MaxLinear is also at a very late release. I'm not sure which one it was now exactly. I don't want to say anything. So that's up to them. We put in the pressure for sure. The OpenWRT, we help out actually. So the part of the prpl OS and the platform work is to help out to make sure that they get up to date and that their SDKs are up to date. Then last question that I have in here, and we're past the end of the slot, so it might be the very last question. The entire security chain is based on keys and public crypto algorithms. How can attacks on crypto algorithms be mitigated so that the images are not susceptible to such attacks? Is there anything new that prpl brings to the table? That goes to this complicated picture here, right? We don't, again, the main focus in prpl is to try to fix the common problems. So is any of this new? No. Are a lot of operators deploying it? very few because it's really hard and really complicated and really custom with the different silicon vendors. So what we've been doing in the security assurance working group over the last few years, and what we will doing in a couple of years going forward, is making sure that everybody has access to this functionality, which honestly is state of the art, but which many people who deploy eschew because it introduces so much complexity that it is a big risk and a big cost to do. So we aim to enable everybody to be able to do this. I hope that that addresses the issue. Are the images susceptible to such attacks? Well, that's the entire security chain tries to defend against those attacks, right? Also, with having a security incident response team going forward, we should be able to handle that better.
All right. Thanks, Wouter. This was really great. And thank you everyone for all those great questions. That was those were exactly why we wanted to do this webinar, actually. And the nice thing is that this is now this has been recorded. We're going to turn it into a video and give access to the slide deck. If you are someone who signed up to with consent for us to contact you afterwards, we will send that out. And then you'll also be able to find this video on YouTube in a couple of days. So thanks again, Wouter. And we are going to put together some more webinars like this, probably more focused on one particular topic. This was more kind of a big overview of where we're at right now at Purple Foundation with the prplWare solutions. So yeah, I think it was really great. And if you have any further questions, definitely email info@prplfoundation.org or any of the working group ones that we mentioned. And we will see you next time.
Thank you, Jason, and thank you for saying that I have a pretty face. I doubt that. I was going for pretty hair, but
That's what does it. All right, cheers, everybody.
thank you. Bye.